Let's go ahead and get started. We're going to talk about section 7.4 today. It's hypothesis testing, and we're going to wrap up chapter 7 and basically chapter 8 as well. That's going to leave us just one chapter left, chapter 9. We're going to spend a few days on it in the next week or so, and then take the test and we're done. Any questions from you guys about administrative type things before we get started?
No.
Okay, you guys got to think a little bit about when you want to take your test. I'm going to open it up first thing in the morning, so it'll be open at 8:30 and it'll go till 12:30. So any time in that 4 hours is good, but you do have to sign in on the, on Zoom so I can see you, check in with me, and then you got to get it done during that 4 hour window. Other than that, I think it's not like an extra long test or cumulative. It's just the chapter 7-9 test, and it's going to look a lot like the ones we've already taken. In fact, it's going to look exactly, well, not exactly the same questions, but the same format as the last test that we took. I'm going to put it on Canvas. It's going to be mostly multiple choice and maybe some fill in the blank short, numerical type answers. And then you can submit your work in Canvas for partial credit. So it'll be the exact same format as the last one. But we do need to take it on, it's Thursday, what is that, the 7th, I believe. We need to take it on the day it was scheduled for during the finals week. And then that's it. Everything else should be available for you in my stat lab. So you can finish up the rest of the homework. If you want to go back and finish some incomplete homework for a few extra points, you can do that as well. And that's going to be open until Friday the 1st. Okay, so you should have all the way through Friday the 1st. Then I'm going to see if I can get it all graded and ready to go. And then all we'll have left is the exam. Okay, so that's the administrative stuff. If you guys think of some administrative things, you can always ask me a question later or send me a note. Chapter 7, it's going to be, maybe we'll see how far we go. I don't have a lot of new material for you today. So I was going to take questions and work some problems if you guys had any that you wanted to see. But let me talk a bit about hypothesis testing to get us started. We've already tested a mean. Essentially, we say, I know the mean of the population. I'm wondering if it's changed or if it's different than advertised, right? If it's not what they say it is. So we take a sample and we look at the sample and say, how weird would this sample be if the mean is what they say it is, right? That's, and then if it's unlikely to get such an extreme sample, then we might say that there's pretty strong evidence that in fact the mean isn't what it was claimed to be. So that's how hypothesis testing works. We test the mean when we know the standard deviation of the population. Then there's not as much to estimate, and so we get a pretty strong feeling for what the mean should be, and we can be more confident, right, if we don't estimate the standard deviation of the population. If we don't know the standard deviation of the population, or we're calling that into question as well because we're estimating or we're checking the mean, we might be concerned that we'd have to check the standard deviation as well. Then we can use a student t-test, and we can approximate the standard deviation of the population using the sample standard deviation. Okay, and that was section 7.3. And so hopefully you got a chance to look at some of those in the homework. Now what we want to do is test a proportion. So a proportion is the percentage of a population that has some characteristic. In fact, I was just listening to, I guess it was the president's COVID briefing the other day. And I heard Dr. Birx say, now what we want to do is we want to test the proportion of the people who are asymptomatic carriers. So she's like literally doing exactly what we're doing today. She's going to go out, she's going to take a sample. She's going to check to see that the sample is large enough, right? So NP and NQ have to be greater than 5. I have a feeling that she's going to check, several thousand people. She's going to get a proportion of the people that are asymptomatic, right? And find out, whether or not the proportion that are asymptomatic are more than or less than or not just plain old not equal to the proportion of the people of the standard population that are presenting with symptoms. So she wants to know, are there more asymptomatic people or not? Right? And so she's going to actually literally test a proportion. In fact, I was listening to the briefing and she said, and she goes, well, we want to test this proportion and then we're going to take this sample and then we want to know if it's statistically significant. And that's exactly what we're doing. We're going to pick a level of significance. Generally, that's given to you in the problem. We're going to say we want to be 90% or 95% or 99% sure. And we're going to go out there and see if our sample data is going to support that or not. Right? That's kind of our plan. Okay, so I would think that you should be, I guess, feeling pretty good about that. That's like what's going on right on the television right now. So how does it work? So let me share with you the book, because I think the book does a nice job on this. Sometimes we look at the notes. Today we're going to look at the book. So here's the book. It says we want to test now a hypothesis test for proportions. Okay, so how does that work? Their example is when politicians want to know the proportion of constituents who favor a certain bill, or when quality assurance engineers test a proportion of parts to see that are defective. Anytime we're looking at whether or not the proportion of the population is what it's claimed to be, or if we want to say that the sample is providing evidence that it isn't. So there are some conditions that have to apply. First, you have to be testing an actual proportion. So we need a binomial distribution. Those are pretty easy to identify because in the problem, it's going to say the proportion, blah, 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 blah. So next we need to know that NP and NQ are greater than or equal to 5. So if the sample is really, really tiny, it doesn't give us enough evidence to make, to perform this test, essentially. And so for a binomial distribution, the sampling distribution of the proportion, in other words, all the possible samples are going to turn out to be normally distributed as long as the sample size is big enough. And so we have to take the sample size and multiply it times the proportion of the population. And so if, we're saying about 50%, let's say, I don't even know what it was. She was saying, I don't remember now for the COVID thing. It's maybe, I don't know what percent, 5% of the population. If 5% of the population are asymptomatic, then you'd have to take that 5% times your sample size. So if you sampled 100 people, then 100 people times 5% would be 5, in which case it would be big enough, right? So you'd have to have a sample of size 100 or more. And if that's true, then the distribution of the sample proportions turns out to be normal, with a mean that's equal to the proportion and a standard deviation that's equal to, and here they give it to you, the square root of PQ over N. Okay, so what do? Here's the guidelines. We're going to first check to see if our sample is big enough. We're going to state the null hypothesis and the alternative hypothesis. So the null hypothesis is always going to include the claim that it's equal to, okay, that it is what we say it is. There's no change, null hypothesis. So we would say the asymptomatic people are not more than and not less than, okay? That the asymptomatic people are the same as just the regular people who are presenting with symptoms. That would be the null hypothesis. The alternative would be the complement to that. In other words, if we say the null hypothesis is that it's equal, then the alternative would be that it's not equal, or that it might be, if we're concerned about asymptomatic cases, that maybe the alternative would be that it's, the null could be that it's less than or equal to, and the alternative would be that it's greater than what it's stated. So we have a bunch of people running around that are asymptomatic, and that would be a problem. You're going to specify the level of significance. You generally don't specify it. Generally, it's specified for you. So they say, test at the 5% level of significance. Okay, determine your critical values. In other words, you're going to look in the table, you're going to look under the standard normal curve, and you're going to say, how far over would I have to be for this to be unusual? As a rule of thumb, more than 2 standard deviations, right? But of course, you can use your calculator to get the exact value here. Then you're going to look at the standardized test statistic. You're going to say, how far from the true proportion is our sample, right, in standard deviation units? So how many standard deviations over is our test statistic? Okay, and then and that's your z-score. Okay, and then you take your z-score. I'm moving things around on my screen a little bit. Okay, you take your z-score and you either do one of 2 things. Either we're doing p-testing or we're doing critical value testing. If we're doing p-testing, you say, you find the area under the curve and you say, is it less than alpha? Right? So if we're testing at the 5%, but there's only a 4% chance of this z occurring, we would say it's statistically significant and we would reject the null hypothesis. If we're doing critical value testing, then we find out that for to be 99% sure, we need to be 2.576 standard deviations away. If our z is bigger than that, then we say it's statistically significant. And again, we reject the null hypothesis. Right? The alternative would be that there's not enough evidence. So remember that to conclude a hypothesis test, there's either going to be enough evidence to reject the null hypothesis or there isn't, in which case we're going to fail to reject or do not reject. But notice that that doesn't prove, right? It doesn't prove that the null hypothesis is true. It just proves, because we've assumed it to be true, right? It just simply proves that there isn't enough evidence to reject it. So hypothesis testing for a proportion works almost exactly the same as it did for a mean, except now the distribution of the sample proportions, okay, is spread out given the formula for, given this formula for the standard deviation of the sample proportions, square root PQ over N. And then we just do a couple. So let's see, here's one. I'm gonna just do a couple from the book. And then if you have some other ones that we want to do, we can do one. So here's the first one. It says a researcher, right? A researcher is claiming that less than 45% of US adults use passwords that are less secure because complicated ones are too hard to remember. Less than 45% use passwords less secure because complicated. 45% can't remember a complicated password. That's what they're saying. Okay, and it's actually less than 45%. So I would have actually thought it might be more than that. But they take a sample, and a sample of 100 adults, 41% say, this means they claim it. They might still be doing it, right? 41% say that they've used these passwords that are less secure. So, you know, what do I use? I don't know, what did I use on the last test? Gaucho, right? It's pretty unsecure. Not enough letters, no symbols, right? Pretty easy to guess. But I guess I was concerned. I wasn't too concerned. I wanted you to remember it, right? And I'm not concerned about people guessing to get in to take a statistics test. Probably not going to happen. All right, so here's what it says. At the 1%, right? At the 1% level of significance, is there enough evidence to support the claim? All right, so let me write a few things down over here to get us going on this. All right, so let me get the important stuff and then I'll switch over so that you guys can see it. So the claim, the null hypothesis, right, is that the proportion is what? We want to test. We want to say that 41% are less, right, are less. So they're claiming that the proportion is greater than or equal to 45%. right? The alternative is, if we reject that, then the alternative is that it's actually less than 45%. So state the null hypothesis and the alternative hypothesis. That's always a good first thing. And then write down all the information. So we want to test at the alpha equals 1% level of significance. And what did we do? We took a sample of 100 people and found a sample proportion to be 41%. Okay, so that's enough of the info. So let me switch back over here. Let's see if I can grab it. Where is it? Oh, there it is. Okay, so get all the information written down. And then I'm going to recommend, at least for the test and maybe for the first few homework problems, that you draw a picture of what's happening. Right? So at a minimum, draw a picture of the sampling distribution of the proportions. So we know that's going to turn out to be normally distributed if our sample size is big enough. So before you draw this, or right after you draw this, you should check to make sure it's really true. So you should check NP, right, which is 100 times our sampling proportion of 45%, which is 45, right, which is greater than or equal to 5, so bingo. And then you should check NQ, right, which is 100 times 65, oops, yeah, 60, wait, 55, got to subtract correctly, which is 55, which is greater than or equal to 5, so bingo, right? Since our sample's big enough, the distribution of the sample means will be normally distributed. So I drew a normal curve. Okay. It's going to be centered. The mean of the sampling proportions is going to be centered at the proportion. And it's going to be spread out, right? It's going to be spread out like the square root of PQ over N. So if we calculate that, we would get the square root of 40, we would get the square root of 45 times 55, right, over the square root of the sample size, which was the sample size, 100 over 100. Okay, so if we figure out what that is, I don't know, let's see, get a calculator out here. We got the square root of 45 times 55 divided by 100. I get 0.128. So what is it saying? It's saying that most of the samples are going to fall plus or minus 13%. So it's going to be centered around 40, it's going to be centered around 45% plus or minus this 13%. How are we doing so far? Good? So now all we got to do is see where our sample turned it out. So our sample, this in the middle here was 45, yeah? So our sample was over here. This is where our sample was at 41%. Okay, so you can see that it's a little bit low. That's good if you're trying to prove that it's less than what they said. But the question is it far enough less, right? So for a sample of size 1, that's not far enough to the left. That's only 4% down. And we know that it's spread out like about 13%. So it wouldn't be unusual to be plus or minus 13% for a sample of size 1. The question is, what about, oh, I'm sorry. This was the standard deviation of the population. Okay, so I'm kind of thinking that 41% is not very far away from 45 if on the average we're about 13. Right, so let's go ahead and calculate the test statistic and find out what it actually turns out to be. So Z is going to be how far away from the proportion you are divided by the standard deviation, right? And so we've got 41 minus the 45 divided by our 0.128. Okay, so what does that come out to be? That comes out to be 41 minus 45, I'm down 4%, divided by 0.128, and I get, that doesn't quite look right. That's what I get. What did I do wrong? That doesn't look right to me. Let me put the numbers back in because something's wrong somewhere. I've got parentheses, 0.41 minus 0.45, right? So that looks good, divided by the square root of P 45 times 55 divided by 100. I think that's it. Woo, that came out a lot different that time. Okay, 0.80. So I'm almost I'm a little less than 1 standard deviation over. So the question is, what happened here? And I think here we had a problem. So let me go back and do that one again. I'm talking about the square root of 45 times 55, right, divided by 100 should be, oh, that's way better. I thought this 13% seemed really high when I wrote it down. How about 0.0497? So how about 0.05? So I don't know how you catch these, you just do enough so that the number looks a little weird, right? But I must have pushed the button wrong in my calculator the first time. It seemed to me like 13% was quite a big spread for a sample of size 100, and maybe 5% makes more sense. Check it out, I'm down 4%. This typical was down 5%. I guess these numbers, I don't know, we caught the error that time, right? It just seemed too big. If you don't catch the error, hopefully you get a red X and then you go back and check your calculation. Okay, but our conclusion would have been the same either way. We're only down a little less than 1 standard deviation. Okay, that's not that weird. So we say there's not enough information, there's not enough, right, evidence here to reject the null hypothesis. So we conclude do not reject the null hypothesis. So it's sure, it's a little bit low, but it's not so low that it's weird. And so we say there's not enough evidence and we do not reject. And then that's it for that one. Questions on that? Same, right? It's pretty much the same as testing the mean, except now you're testing a proportion, but it's the same, it's basically the same steps with a little bit different calculation. So let me try one more with you. How do I get my book back? Here we go, share book. Okay, and so as you can see in the book, let's see, what did they get? They got negative 0.8 as well. And then down here, they say there's not enough evidence. Okay, so we managed to get that one right. That's good. So let's try another one. So here's example 2 from the book. This time, we want to check that 51% of adults believe incorrectly that antibiotics are effective against viruses. Seems like all these virus questions are all over the place now. It's kind of making me, I don't like viruses myself. I'm kind of creeped out by them. Okay, so 51% believe that antibiotics are effective. Well, they're not, because biotics means they're good for biological things, and I guess viruses aren't biology. It's weird, huh? Kingdoms, and again, phylums. Anyway, antibiotics don't help. And so if you go and get this coronavirus, then pretty much they can't give you much of anything. You just kind of have to get over it or you don't. So what do we say? We say maybe the United States population is smarter than that now, right? With all this virus publicity that's going on the TV every day, maybe we're getting better. So maybe fewer, right, than half of the population actually knows how antibiotics work now. And you want to test that. So you go out and you ask 2,202 adults, why that many? I don't know. But 1,100 say that antibiotics work. And unfortunately, you're feeling a little bad about this, right? Because that's still a little more than half. I'm kind of feeling like maybe that's not enough evidence. I was kind of hoping that maybe only, 500 said that they were effective, which would have been, only about a quarter of the people instead of 51%. We would say, oh yeah, that's definitely statistically significant. So since this is real close, we're going to have to run the numbers and find out how it comes out. Now, because this claim isn't, maybe it's not that important. It's just like an interesting fact about, the U.S. population. We can test at a higher significance level. So we could say, I only need to be 10% sure here instead of 99%. Sorry, I need to be at the 10% significance level or 90% sure, as opposed to being 99% sure. Okay, so we're going to see if this works out. So here comes testing it. So what I would do is I'd write down all the interesting stuff. First of all, the researcher claims 51%. So we want to test, right? We want to test that it's not 51%. We don't care if it's more or less. We just want to see if it's not what they claim. So our null hypothesis is that it's 51%, and our alternative hypothesis is that it's not 51%. And we want to know, has it changed, right? Has it gone up or down, given all of our current news? Then we take a look at all the info. So N was 2202. And then we actually, in this case, found 1161, said yes. Okay, alpha was 10%. And then I think that that's all the information from the problem. So let me switch back so you can see my writing. Again, I would draw a picture. I would say all the sample means, okay, are going to be normally distributed as long as, and we'll check off here to the side, NP and NQ are greater than or equal to 5. So first, since we don't know P, right, you're going to have to calculate it in this particular problem. So what's P? P is how many said yes out of how many there are. So I'm thinking the proportion is 1161 out of 2202. So we got a proportion of 1161, 2202. We got a proportion of 527, 52.7%. So let's see, it used to be 51%. Now it's 52.7 in our sample. Oh no, that's worse. People are getting less knowledgeable about antibiotics, right? So now we can check NP. So NP is what? NP is the 2202 times the 0.527. Check out what that is. That's the number of people that said yes. So that's going to turn out to be our 1161 again. In other words, 1161 said yes, and NQ, how many said no? 2202 minus 1161. So that's 1041. And in both cases, these are greater than or equal to 5. So boom, we're good. that means that the sample proportions will turn out to be normally distributed. With a mean, right, the mean of the sample proportions will be equal to the proportion, right, which is 51%, and spread out, right, and spread out like the square root of PQ over N, which in our case is going to be 51 times 49 over 2202, which is going to be square root of 51 times 49 divided by 2202. I've got 0.01106, so I'll round it off to 11. Okay, so now all we have to do is see if our sample proportion, right, is, where was our sample proportion? I should have called it P hat, right? P hat, our sample proportion of 52.7 is weird enough. So here's 51, here's us, right? Here's us at 52.7. And we want to know, is that weird enough? Well, it's 1.7 standard deviations over. One standard deviation is 0.11. So it's a little more than one. We don't think that that's very weird, right? Until you get to about 2 or so. Okay, so let's do rejection region testing this time. In other words, we want to work at the 10% level of significance. So we're going to find the z's, right? The z's that would cut that off. So what we need is 90% of the area to be between the z's. That leaves 10% outside the z's. That means over here, we'd have half of alpha, or 5%. So we need the z that cuts off this last 5%. Oops, sorry about the focus. That means that on this side, there'd be 95%. So to do that, we would find z sub c to be the inverse normal of 0.95, right? Because it's got to cut off 95% of the area over here. Okay, so what z is that? We go on here and we say, I think that z distribution inverse normal 0.95, we get minus 1.31. That looks wrong. Having some trouble typing this morning. Notice that minus 1.31 is definitely not on this side. So it's a pretty good place to catch your error, right? This could have been minus 1.31, but this one on this side definitely is not. Okay, so then you'll look back at what you typed and you go, oh, hey, you typed 0.095, not 0.95. So try again, 0.95, and we get 1.645. That should look familiar because that's the same cutoff that we've been getting for the last, month now? And so maybe you're getting to the point where you don't even really have to calculate this number. You've just memorized it. That's okay. You can just memorize it. That's fine. But you should write it down for me if you want me to look for your error. Because if you type in the wrong one, I won't know that you knew it and typed it wrong or what happened, right? So if you want some partial credit, then you'll show your work like I'm doing here, and then I can look through and, if you just did a typo, I don't know, then I can take off the smallest amount possible. Okay, so what does this say? This says that this z sub c is 1.645, and this z sub c is minus 1.645, and I'm wondering, where did ours lie? Okay, ours is right here at 0.527. So is it far enough over? I don't know, we'll have to test it. Our z, right, is 0.527 minus 0.51 over our standard deviation, which was 0.011. So ours is 0.527 minus 0.51, okay, divided by 0.011. Ours is 1.545 or 1.55 over. This only made it over to like here. We needed to be 1.645 to have enough evidence. So, hey, 2 tests in a row, we don't have enough evidence to reject. Do not reject. H not. You could say there's not enough evidence in this sample. So what could we do? We could take another sample. We could take a bigger sample, right? We could try to educate the population a little bit more. That would be good, and then do it again. Those are all things that we could do to be able to test. Okay, so in both of our examples this morning, we didn't have enough evidence to reject. And then I would say, there you go. I would say that's a pretty complete, notes or work or showing your work to say, yeah, okay, I got it. So if you had a little typo in there somewhere, right, then I could probably give you like 9 out of the 10 points for it or something. Here are the steps. State the null hypothesis and the alternative hypothesis. Okay, next, find the sample proportion and check to see that the sample proportions are normally distributed by checking NP and NQ are greater than or equal to 5. Draw a standard normal curve for the sample proportions and figure out what the mean and the standard deviation are. Then look at your particular sample and say, how far away from the true proportion is it in standard deviation units? And then to make the conclusion, you're going to say, compare it to the critical value or compare the area to the level of significance. And so if you have less area than was needed, you say reject. If your Z value is is more extreme than the critical values, then you reject. Otherwise, you do not reject. And then that's how this whole thing works out. Okay, so there's another example. There's a couple of them. I'm hoping that there really isn't too much more in this section. Here, let me get it back up for you. Share screen. Okay, what did they get? 1.60. So notice that they did a little bit of rounding earlier than we did. We got 1.55 because we didn't round quite so soon. They got 1.6. Either way, there's still not enough evidence at the 10% significance level. So there are a couple in the book. If you're confused, you want an example, go back and look at the book, and then you can follow through these examples a little bit more. And then I think that's it. Yeah, the next page are the exercises. So I guess it's time for you guys to go out and try a few. Make sure you've got this down. Find a piece of technology that's going to work for you. So whether you use, whether you decide to use the calculator or you decide to use StatCrunch or Excel or something like that, make sure that you're comfortable with performing the test using your technology. And then I think we should be good on chapter 7. How about any questions? I'm going to stop sharing so I can see if there are any in the chat. Questions? Anything from the homework that you've got stuck on that you want me to work out?
Nope.
Okay. If you run across some as you're working on this homework, then please send me a note and I will keep an eye on it over the weekend and try to write you back as soon as I can. Otherwise, I think that's it for hypothesis testing. And normally we would do a little bit of chapter 8 and then kind of take a test right here. It's going to be a little weird for us because chapter 9 is a new topic. But I think I'd rather just do one test rather than 2 small ones. And so We're going to wrap up hypothesis testing. And then when you guys come back on Thursday, we're going to start talking about chapter 9. It's about correlation and regression. It's a little bit of a new topic, but it's our last one. And we're going to do 3 sections of chapter 9, and then we're going to be done. So I am going to let you guys go. Have a good couple of days. And like I said, if you need something from me, you can always check back in during office hours or send me an email.
Thank you.
Okay. Have a
Thank
great
you.
couple of days.
Thank you.
Mhm.